All right, it's time to discuss special right triangles. So these are the content standards and the mathematical practices we'll be using in our assignment. Previously, you've used properties of isosceles and equilateral triangles. Now we're going to use the properties of a 45-45-90 triangle and a 30-60-90 triangle. The diagonal of a square forms two congruent isosceles right triangles. Now, since the base angles of an isosceles triangle are congruent, the measure of each acute angle is 90 divided by 2, which is 45. Such a triangle is known as a 45-45-90. You can use the Pythagorean theorem to find a relationship among the side lengths of a 45-45-90 right triangle. This algebraic proof verifies the next theorem. So we're told that the legs are equal and the hypotenuse is the leg times the square root of 2. Knowing that, we're going to find the hypotenuse length in a 45-45-90. So given the angles of this triangle of 45 and 90, we know that 180 minus 45 minus 90, we know the other measurement is 45. So this triangle is a 45-45-90. We know the hypotenuse is the length times the square root of 2. The length is 9, so x is 9 square root of 2. Now we're going to try to find the hypotenuse. So the legs are the same measure. We know the hypotenuse is one of the legs times the square root of 2. So the leg is 6 square root of 2 times the square root of 2. The square root of 2 times the square root of 2 is the square root of 4. And the square root of 4 happens to be 2. So 2 times 6 is 12. Now it's time to check your progress. So pause the video for a moment, work the problem, then come back and check your answer. All right, did you get 7 times the square root of 2? So we know that the hypotenuse is the length times the square root of 2. The leg is 7, so 7 times the square root of 2. Let's try another one. Now let's find the hypotenuse. So pause for a moment, then come back and check in a bit. Very good. We know the hypotenuse is one of the legs times the square root of 2. So 8 square root of 2 times square root of 2 is 8 times 2, which is 16. Now you can also work backward using the 45-45-90 triangle theorem to find the lengths of the legs of a 45-45-90 triangle, given the length of the hypotenuse. So we know that the length of the hypotenuse is the square root of 2 times longer than the leg, because the hypotenuse is the leg times the square root of 2. Well, so the hypotenuse, 8, is equal to a times the square root of 2. Now we're going to divide both sides by the square root of 2. Then we have to rationalize the denominator. We've got to get rid of the radical that's in the denominator. We do that by multiplying by the same thing that's there, whatever's under the radical. So there's a square root of 2 here, so we're going to multiply it by the square root of 2 over the square root of 2. Whenever you multiply by 1, it doesn't change your original expression or equation. So we have 8 square root of 2 over 2, and then 8 divided by 2 is 4. So a is 4 times the square root of 2. Time to check your progress, so pause for a moment and come back and check your answer. Okay, so we know the hypotenuse, the 6, is equal to this times the square root of 2. So 6 is equal to b square root of 2. We divide both sides by the square root of 2. Then we rationalize the denominator by multiplying by square root of 2 over square root of 2. We end up with 6 square root of 2 over 2. 6 divided by 2 is 3. 3 square root of 2. Now there's properties of a 30-60-90. Now, a 30-60-90 is another special right triangle or right triangle with side lengths that share a special relationship. When an altitude is drawn from any vertex of an equilateral triangle, two congruent 30, 60, 90 triangles are formed. This is the algebraic proof that verifies the 30, 60, 90 triangle theorem. Now remember, the shortest side of a triangle is opposite the smallest angle. I'm going to say that again in case you've not picked up on that before. The shortest side of a triangle is opposite the shorter leg, or the smallest angle. So the shorter leg in a 30, 60, 90 is opposite the 30-degree angle, and the longer leg is opposite the 60-degree angle. So we're asked to find x and y. Now the acute angles of a right angle are complementary, so the measure of the third angle is 90 minus 30, or 60. So we're going to find the length of the longer side. Well, we know the longer side is the short side times the square root of 3. So x is equal to, the shorter side is 4 square root of 3 over 3, and we multiply it by the square root of 3. So 4 times 3 will be 12, so 12 divided by 3 is now 4. Now let's find the length of the hypotenuse. The hypotenuse we know is 2 times the shorter side. So y is equal to 2 times, and the shorter side is 4 square root of 3 over 3. So 8 square root of 3 over 3. And that is our answer. X is 4, y is 8 square root of 3 over 3. Time to check your progress. So pause the video, work the problem, come back and check your answer. Okay, to find the length of BC, to find that hypotenuse, first of all, we need to figure out what the short side is. Well, this is the long side because it's opposite the 60, and we know this long side is equal to the short side times the square root of 3. Well, if 4 square root of 3 is equal to the short side, or s square root of 3, we divide both sides by the square root of 3. We find out the short side is 4. And now we know the hypotenuse is 2 times the short side. If the short side is 4, 4 times 2 is 8. Now we're going to use the properties of a 30, 60, 90 and a 45, 45, 90 triangle and solve real-world problems. So we have a quilt design, and we have all these squares. It's divided into 8 isosceles right triangles. If the length of one side of this square is 3 inches, what are the dimensions of each triangle? So first of all, if this whole thing is 3 inches, what is the measurement of this one side? Did you get 1.5? Well, very good. So the side length is 1.5. We know the hypotenuse is the length times the square root of 2. So we're going to substitute in that 1.5 times the square root of 2. So the side length is 1.5 inches, and the hypotenuse is 1.5 times the square root of 2 inches. We can use the Pythagorean theorem to check our answer. Is 1.5 squared plus 1.5 squared equal to 1.5 times the square root of 2 squared? Yes, good. We got the right answer. Okay, time for you to check your progress. So pause for a moment, then come back and check your answer. Did you get 5 square root of 3? Well, we know that the short side, the 30 is opposite the short side. Since we've got the 60 and the 90 labeled, we know that this 5 inches is the short side, and we're asked to find out the height of the bookends. So it's opposite the 60. We know that height is the long side, and the long side in a 30, 60, 90 is the short side times the square root of 3, or 5 square root of 3. Very good. You're ready to start your assignment now.